See if the audio is working. I see the meter bouncing, so it's good. And hopefully I don't have too much talking to do today because I am still getting over a flu or a cold or something. And I'll get started right at 12. But essentially today I'm going to have a sneak peek of a future case I'm putting out. And after that, it'll be quick. It'll be a quick sneak peek, and then I'll basically be streaming, trying to repair a hotend clog that I had that actually stopped the progress of this new case. So let's see how this goes. And I'll be sipping on this disgusting little elixir I made. Essentially, it's like ginger, citrus, and honey that you can get a big jar at Costco. And then I threw in some Dayquil in there for the mix. So it's going to taste disgusting, but hopefully it makes me feel a little better, and hopefully it eases some of the pain I have in my throat. But this is the first sip of this concoction. Yeah, disgusting. And we'll just wait a little longer. And I also have this new camera that follows me around. It's the Ozbot Lite 2 or something like that. It's pretty neat. It'll do pretty good face tracking. I should set it so that it like faces my chest, but what can you do? Alright, so essentially I do have a new case coming out. Unfortunately, it's been delayed because my printer here has a clogged hotend, and yesterday I tried all the things necessary to try to get it fixed. I had basically the hot end removed but still connected, and I tried using the needle while it was hot to try to get the jam out, and for some reason I could not get the jam out. And so I've actually taken the, I think you can zoom in here really quick. Nice. Okay, so I have the hot end here and the heat break over here, and they're both kind of clogged. And so I have tested it out, and this is how you zoom in and zoom out. I have tested it out, and filament can go through the gear mechanism, so there's nothing stopping that. And I have also, I can push, so Cheaty Tech gives you like a, let me zoom in really quick on this. Cheaty Tech gives you this little vial that has an acupuncture needle. It's really hard to see probably on the camera, but let's see, how do I do that? Yeah, but it's hard to see. It's thin. It's supposed to fit in inside a 0.4 millimeter nozzle, and weirdly enough I was able to push through the needle and have it slide through, but then when I tried to push any filament out, it just wouldn't go out. I couldn't even force it by hand, and so I've had to resort to taking out or disassembling the hot end and the heat break so that I can hopefully get it out. But before I do that, let me talk about the new case I have out. Now, my Patreon members have a better view of what the case is going to be, but just to spoil everything, let me just show you what I got here. Okay, so this is an old micro ATX motherboard I have with this pretty large heatsink, and so you can kind of guess that the new case is going to be micro ATX. It's going to be compatible with fairly large air cooling, so you don't have to rely on just water cooling now. Let me zoom out really quick. Alright, so yeah, so it's going to be micro ATX, huge cooler, and sadly this is the only power supply I have that's like what I'm designing around, but it's a full ATX, 140 millimeters deep. The other sorry, the other ATX power supply I have is like 200 millimeters, and I'm not going to design a small case around that. It's too large, and so, and I have found that a lot of power supplies are around this depth. So, it's got the normal height, normal width, but the depth is going to be 140 millimeters, and it will definitely work better with a modular power supply. This is obviously non-modular, but when the case is finally done, I will show you that it is going to be possible to use even non-modular power supplies. And of course, it's going to be fitting a like full-size GPU. Now, theoretically, with the case design I have, it should fit a RTX 4090. I don't have one to test out, but I did find dimensions and I did find dimensions and some models online, but I ended up just creating like a rectangular box that represented the dimensions that NVIDIA was posting. And then I also gave it some clearance for the 12 volt horsepower connector, whatever it's called, but it's got like a good like maybe 20 millimeters of clearance for that cable, and so theoretically this new case should work with all of that. And one other bonus is that it is going to work with smaller printers, and so, and because of that, I did have to basically segment the parts again, and I looked into other like joining mechanisms for panels, and quite frankly, I did find one by this this one YouTuber. I think his name was like PAL or something like that, but I'll send a link later on. But essentially, he had like a locking mechanism that had like different surfaces, but it did look like it was going to work really well, and I think it would have fit the aesthetic of the case, but the way that particular joinery was designed, it just would have been too much work, to be honest. For my cases, again, my cases are going to be free for everyone to use, and so I basically am not going to charge you for them, and at the same time, too, you should be expecting a case that's not exactly like fully refined and also like maxed out in terms of development, and so I didn't feel like it was, I guess, worth it for me to design this new panel system. And so I've resorted back to the same panel system that I use for my steam machine. And so we are, again, going to be using like a lobe system. And so we've got these lobes here that basically connect. And these are just some tolerance tests I've been doing. I believe actually the first one is this one here. And so in my previous printer, I had the Artillery X1, and it had really poor tolerances. And so this is the first test I did using the same tolerances I used for the Artillery X1. Now for the Artillery X1, I believe I landed on a tolerance of 0.25 millimeters, and that created a pretty tight interface fit where I had to use like a hammer to actually get everything together. But this new Cheaty Tech X Max 3, it's a lot more precise. It's also helped by the fact that I'm using a smaller nozzle on the Cheaty Tech. My Artillery X1, I did upgrade it to a 0.6 millimeter nozzle, and so I guess there's definitely a lot more room for filament to kind of creep or whatnot, and so having the smaller 0.4 millimeter nozzle on the GT Tech does help its I guess accuracy. And so trying out my previous tolerances for the Artillery X1, it just didn't work out. So I think over here is 0.1. Let me zoom in actually. Okay, so it's 0.1 here, 0.25, and then 0.5. And you can see that basically I wanted this to be an interface fit so that it would stay together without any glue. And what you're seeing is like it can just come apart pretty easily. And so I went even further down, and so what we have here is 0. Oh, sorry, this is 0.1. I believe this is 0.05, 0.01, and even then these came out. And so like basically what I'm finding is that the accuracy of the Cheaty X Max 3 is pretty impressive. And so none of these tolerances even worked. And so for my last one, and also what I've landed on, so this part here is 0. There's absolutely no clearance whatsoever. I believe this is 0.01, and I believe this is 0.025. And so the 2.5, they're all pretty darn tight and pretty straight, but the 2.5, I can still kind of feel the material. You can even hear the material kind of separating. And the 0.01, there is definitely still some flex you can feel and hear. But what I ended up landing on was the 0. Like there's no tolerance whatsoever. So for this side here, it's 0, and this is what I landed on. And so it's kind of amazing that the Cheaty X Max 3 is so precise that I was able to use a 0 tolerance for this interface fit. And so that's what I'll be going with to put this case together. And the hope with that is that I won't have to use any adhesive, but obviously if you want to have a more secure fit, adhesive won't hurt. And let me actually show you some of the successful prints. Let me zoom out really quick. Okay, so I did have some successful prints, and so this is one of them, or two of them exactly. So this is the rear of the case, and so you can see I do have room for a 120 millimeter fan. There are 4 slots available for this case. You do have a little pass-through for the power connector, and to be honest, it's actually not needed, but I put it there anyways. And obviously this is where the motherboard's going to be. But you can see the lobe system that I'm using to join them together. I won't put this together yet because I think I'll save that for the actual stream of the case when it's finally finished. But I can show you where this project kind of stalled. So I was printing out this piece here, and literally, like, oh, so TechG says hello from Brazil. Hey, what's up, man? Yeah, Brazil. It's funny. I've had a few viewers from Brazil, so you guys really love your tech there, which is awesome. And I don't know if you were in the previous stream, but we were talking about this one time I was planning a trip to Brazil just to take a trip down the Amazon River and do some journeying with like a tribal master. But we won't talk much more about that. But yeah, I think it's still going to be in the future, but we'll find out later. But anyway, so this was the field print, and so what you're seeing here is like almost like 90+% of the print being finished, and then literally for the last 10% it just clogged, and I couldn't print out the last like 10 millimeters of this thing. So as an example, this is the previous beam case that I created, and let me just take it apart to show you what we're actually missing on this particular print. It's so frustrating because honestly, if this had completed, I would have been able to put the case together, and it would have been essentially, it would have been this, and I could have shown you a somewhat finished product of the micro ATX version of this, but it just didn't finish. Like it's hard to see. Let me just zoom in really quick. So over here, you'll see that there are tabs. Actually, is it zoomed in? There we go. Okay, So there's tabs over here that connect to the maker beam. Uh, I guess what would you call these beams or what have you? And essentially, all it needed to print for this guy was just these tabs that connected to the beam, and it would have worked. But literally, the last 10% of this was stopped because of a clog. And I thought that I could like clean up the clog, clear it out, and just restart the print. I think so. For my printer, particularly these two parts took 4 hours, and I thought I could just restart it and then wake up today and then start some other prints that would have only taken like 2 hours, and I could have just. My goal today was basically to have like something like this to show you all, and then to also just put all the parts in, because right now this actually works as a case on its own. You just don't have all the side panels and the top panels, but those aren't really necessary for the case to actually work. But yeah, that was my plan, is to have that done and then show it to you all and be super stoked on it. But then, of course, like Murphy's Law, like if something needs to go wrong, it will go wrong, and it went wrong. And so I actually tried fixing this hot hand issue for like a good 3 hours. I think I went to bed pretty late. I was feeling pretty crappy too. But I did put this thing together. So this is actually two prints. As you can see, let me just zoom in really quick here. As you can see there, you can see the lobes, very similar to the test prints I used here. And basically, let's see, sorry, I'm messing with the camera, but so you see the interface fit here. It's pretty darn straight, I think. And, you know, once it's inside the case, it'll be held up by the maker beam posts that I have here. So the idea was that these were supposed to attach like this, and then obviously this back panel was supposed to attach like this. So, but again, that never happened because the hot end clogged. But as you can see here, it's a pretty large case, in my opinion. It's obviously not as large as the ATX case that I made prior to this, but both of the ATX cases I created, they all required a riser cable for the graphics card, and to be honest, I hate those things. So if you remember, I took apart my old Sliger SM570, and I forgot to mention that in the stream, but one of the reasons why I was really driven to take it apart and basically recoup some of the parts inside there was that the riser cable, I think, died on there. And now it wasn't dead in that like I couldn't play games anymore, but my video card was running at like it was still running at 3.0, but I think it was only running at like 8x. Now, I don't know if it was, I mean, I should have verified if whether or not the cable was the issue, or if it was because maybe it was sharing PCI lanes with like an NVMe drive. I don't know. Actually, no, I do know, because, so right now, I'm going to zoom in really quick. So after that stream, I mad scientist this little contraption. Come on, follow me. There you go. So what you're seeing here is the old system inside the SM570, and I hooked up the video card. Oops, it lost me. I hooked up the video card to like a 360 millimeter radiator, and then I have the CPU on a, let me zoom out really quick. And then I had the CPU on like a 120 millimeter fan or radiator, and right now it runs at you know, it runs at 16x 3.0, and so for sure it was the cable doing it then, because right now it's still, I haven't changed any of the NVMe drives out of there, and so if it was sharing lanes, it's still doing it, but it's still showing as 16 at 3.0, and so for sure the riser cable has either lost some lanes or what have you, but it's always been like, I've always been wary of those cables. I mean, you are like outputting tons of data through those cables, and so any little thing can really like screw it up. I've had friends who've had to basically like change cases and also like buy new riser cables because theirs crapped out, and so I just don't trust them. And so for this newest one, for this newest case, I basically wanted just air cooling, ATX power supply, micro ATX motherboard, no riser cable, full size GPU, and yeah. So I'm looking forward to sharing that with everyone. And again, this is kind of like a sneak peek to what that's going to be. And if you have any questions about that, let me know. And for my Patreon members, they've kind of gotten some like clear photos and renders of what it's going to look like. The one I shared on YouTube was kind of blurred on purpose. Yeah, just kind of advertise the Patreon. But yeah, I'm very excited for that. I think if I can get this hot end situation figured out, it should be done by next week. And so hopefully next week I can stream it, and we can get a new case shared with everyone. And yeah, pretty excited for this one. So again, this is the width of the case, and so you can see that you can definitely fit like a large air cooler within there, and you won't need to use a riser cable, so that should be fun. All right, and if no one has questions about that, you can feel free. If you just came here for the sneak peek, that's all I'm going to show, because in reality, I just wanted to, just basically, I did say I was going to stream, and so I didn't want to backtrack on that, and so here I am streaming. But for the rest of the time now, I'm going to try to actually fix this hot end issue. And I've done this before, but I think I've done it wrong in the past, and so I do have a steel hardened nozzle on here because I do use a lot of filaments that are they have like glass fibers or carbon fiber. Like this is used with carbon fiber, and it is abrasive, and so you have to use a hardened steel hot end on there. But in the past, what I've done is actually like whenever I had a clog, I would just take a blowtorch to it and then kind of like literally just blowtorch it till it's glowing and then dunk it in water, and it would just like clean itself out, like super simple. But I have learned since that by doing so, you actually lose the hardening process on the material, and so I don't want to do that. But I will still be heating it up, but I'll be heating it up within temperatures that are basically it's designed for, and so I don't want to like exceed like 300 Celsius on there. And to do that, let me see if I can come over here and maybe zoom in. I am going to be using this. I'm like squatting and it's like really hard, but I do have like a little hot air station over here. Let me zoom out really quick. And that's what I'll be using to basically heat it up and hopefully get that clog out of there. And so without further ado, I'm going to get started on that. And so yeah, so the sneak peeks are over. Now if you want to stick around and chat while I try to get this hot end cleared out, feel free to stick around. And I'll probably stop in like maybe 30 minutes because I don't think you guys all want to watch this thing happen because I don't know how exciting it's going to be. So right now I have my I have the hot air station programmed to achieve 300 degrees Celsius, and I'm gonna see if I can get it zoomed in to where I'm working. So let me come down here really quick, and then zoom in, and then this is how to stop the following. All right, cool. You won't see my face anymore. That's okay. And so basically I have the hot end here, and then I have the heat break here. And right now they're both kind of, I wouldn't say clogged, but you definitely can't put a, like right now I have this, this little needle here. And the idea is that, you could theoretically just like push this through and push out the clog. And that didn't actually quite work in the past, and so my plan right now is to heat this thing up, and then see if I can push out whatever clogs in there. I don't know if it's going to work actually, but let's find out. And worst case scenario, again, that's why I think I'll stop the stream at like 30 minutes. So right now it's like 12:30. We'll stop at 1 o'clock. And basically, if I can't do this, I'll probably just have to buy a new hot end to make this happen. I do have a new hot end. It's like but it's a 0.6, and so when I designed this new case, it was designed around 0.4, and you probably could get away. Excuse me, my gosh, you probably could get away with just printing it with the 0.6 nozzle, but in reality, a lot of the design decisions were made around a 0.4 nozzle, and so I don't think there's any point in trying to like change that or try to print around that. So if I can't get this one fixed, I'll just buy a new 0.4 nozzle, and then hopefully fix that, and then hopefully finish the prints, and then maybe later on in my future cases, I actually will utilize the 0.6 nozzle because it should be faster. But the one thing is that I don't want to really tune for that new nozzle, because that's something you definitely have to do, because like the physics are all just different with a larger nozzle. And what's great about Cheaty Tech is that the profile they had for the 0.4 worked really well, especially for the carbon fiber PETG. And so I know that I can't just like use a normal profile for the 0.6 nozzle. I don't think this is getting hot enough. Never mind, I take it back. It is getting softer. And so right now it's definitely the filament's too soft for the thing to go through, but sorry, yeah, so it's not melted enough to go through. Actually, no, I take it back. It's hard to see on camera, but it is actually through. So it's so strange. So I can put the needle through. It's kind of getting stopped because I think it's just not hot enough. But yeah, I can get the needle through. You can see it took some stuff out really quick. How do I even show this? Maybe like by the handle. Yeah, there's like gunk on the needle. But not enough for it to be like smooth. Let me see. I had this brass brush over here, and there is some filament. Like, I don't know if you can see that. You probably can't. Actually, you can sort of. So if you look here, there's like a white circle there. That's basically like filament that's like coming out. And originally I thought I had like a hot end or a heat break leak, but it wasn't the case. And so I really think there's just something like lodged inside this, either inside the nozzle or inside the heat break. And so right now I'm just heating it up and hoping that I can kind of dislodge whatever's in there. And if this is too loud, let me know. I don't think it's too loud. You probably heard like the person outside starting their car over this, but who knows. So right now I'm just heating it up, the needle as well, and let's see if I can try to push it through. Now, if you've ever done this, it's literally threading a needle. It's like easy, but not. Especially when you have like shaky hands right now. I have shaky hands. It's like I'm doing this on camera. Actually, let me go try going from the back again really quick. Yeah, so it kind of goes through. It's not the easiest. I don't know if you can see it on camera. You probably can't. You can kind of see like a little shadow right over here, but the needle definitely goes through. But that was also the case last night. Like I was able to put the needle through. It just didn't like flow right. Like I couldn't push the material through easily, which was really frustrating. Like I was at it for like a good like 2 hours. Like I should have just gone to bed, to be honest. But I really wanted to show you guys the new case, and I basically just lost so much time. I'm trying to. Okay, I have the needle in from the front, and it's just not getting hot enough, I think. Maybe, hold on, this might be naughty, but I'm gonna bump up the hot air station to like maybe 350, because even if I do set to 350, like the air itself is not going to be that hot. Maybe we'll do like 325. Now that's definitely like way hotter than I think the actual hot end is designed for. I don't know if you can tell, but it's actually making my like one of my lamps like flicker right now. It's pushing tons of wattage through. It might just not be hot enough to do this. So I don't know if you've heard, but in my previous clogs, I would literally like take a blowtorch to these things, but I've decided not to do that anymore because apparently it can destroy the hot end. Or maybe I am touching the clog right now. Who knows? Because it doesn't want to go in anymore, but it also doesn't want to go out. So I think it's just cooled down too much. But if you have any tricks on getting clogs out, let me know. I've tried even like a what they call a cold pull. I think I posted like a little photo last night about it, and like I would keep doing it and I would see debris come out, but like it just wouldn't like fully um it just wouldn't fully clear. Like I as many times as I did it, it just did not want to like actually clear it. It's so frustrating. And in my head I was thinking like, man, like right now I wish I had a Bamboo Labs printer, because I bet they don't have to deal with this. But if you go on YouTube and you search like how to clear out a clogged hot end, it's like a lot of them are like actual bamboo printers too. So I'm like, I think it's just the nature of the beast, right? Like as precise as these printers can get, and as precise they can get to creating the filaments, I think you just can't help but like just deal with the nature of like manufacturing these materials, like the filament. Like you just can't guarantee that's clear. It could be that like the filament I was using had like dust on it. Normally before I start a print, I will like take a what do you call it, a duster to the filament so that I can like clear off any dust. But obviously that didn't really help, because I think I had started these prints I believe it was like Saturday morning. I was like sick from like Wednesday till like I want to say like I guess like I'm still kind of sick right now, like and so I didn't really get to do much, but I at least got the print started. I was able to get like this done, this 90% done, and I have a whole bunch of like other pieces I also printed out because I had some filament to like kind of burn through. And basically I was on track to having everything finished to show you all, but unfortunately this clog just kind of stopped everything. So if you can see, I'm able to now like freely pass this needle through my hot end pretty easily. Now this looks promising, but to be honest, last night was the same situation. When I had this inside the machine still, I was able to pass the needle through pretty effortlessly, but then the filament would then come through like within like maybe like 5 millimeters, but then later on it would just clog right again. So I was like, man, it was so frustrating. So I know you're not supposed to go through the other end, but let's just do it. See right now, so I'm able to, again, go through both the front and the back of it. I just don't get it. Like, what is in there that's stopping me from just finishing this darn project? So I'm pretty excited for the case, and I know I'm jumping ahead, but after I finish this case here, I have another case design in mind that I want to pursue, and it should be fun. It's not really like quote unquote practical, but it should prove to be fun. And I want to try to clean off the top of this thing because ideally you want this part pretty clean so that when you do put it back inside the heat break, they'll have like a really tight fit to it. But yeah, for some reason, like this, maybe this hot air station just sucks too. I mean, it is like some no name. I can't even pronounce the name of it. It's like Yihua. I don't know how to say it. Or is that an F? I think it's an H. So it's like a Yihua 8786D. I don't know. It's so basically this is the hot air station that I have that also has a soldering iron to it, but I think I've only used it like once or twice. But yeah, most of my soldering is actually done with like the really crappy soldering iron that I have that people made fun of in the comments. But I do have this as a hot air station, but maybe it's like not good enough. Like I'm able to put my hand like pretty close to it and it's not really like burning me. Maybe that's not a good sign, but I'm just afraid. I do have a heat gun, but like it says it goes up to like 500 degrees Celsius on like its low setting, and so I think that's way too high for this hot end. Normally this brush works like pretty well when I'm just trying to get stuff off, but I think it's just like not hot enough. Let me see if I can take tweezers to it or something. I'm basically right now I'm trying to get off. You can see that there's like filament on the outside of it. I'm just trying to get that off so that when I do put it in the heat break, it has a more of a metal to metal interface. I know that if I just squeeze it, it'll come out anyways. That's not happening. Maybe it will happen, I don't know, but I just feel like I didn't get the clog out. If the clog was in here, I still think it's in there. What if I go backwards? Or actually could this thing? So I had this like really small Allen key that I have, and I was reading online, apparently people use that to like basically clear out like the heat break. But let me see if I can get it through this thing too. No, it's not working. Maybe that's good enough. Maybe when I put it in, it'll just squish out instead. So maybe I can move to the heat break, but I don't know if I can get the heat break hot enough for what I want. So what I want to do with the heat break is, again, push this needle through and then maybe even like shove this guy through, because this guy technically should fit within the heat break to push out whatever I have in there. So maybe let's try that out. So let's forget the hot end for now and let's focus on the heat break. So what I'll do is I'll just heat up this side first, and hopefully it will get hot enough so that because there is definitely some filament in there. I can't even push through this needle. Well, it's the same way with the hot end, right? I couldn't get the hot end through because there was filament inside there. And so let's see if I can get this hot enough so that I can at least get this needle through, because it's been kind of stuck in there. So Chris, so I want to see the case. You came in a little late, but basically all it was sneak peeks, Chris. So let me zoom out really quick. Okay, it doesn't want me to zoom out without my face in there. Okay, so Chris, basically this is just a sneak peek of the case coming up, and as you can see, it's fairly wide, fairly tall, and basically it's going to be using micro ATX air cooling, so it's gonna be able to accommodate pretty large air coolers. It theoretically can fit a RTX 4090, and it also basically has mounts for a full size ATX power supply as well. So again, these are just sneak peeks, and here I have like a non-joined back panel. So as you can see, it is fairly large. It's still technically SFFPC because I think the actual volume is still going to be whatchamacallit. It's still going to be below 20 liters, and so it still qualifies as SFFPC. But the advantage is that I think it'll basically allow most users to use it because, again, micro ATX, full size ATX, and air cooling. And the neat thing too, because I am doing joinery, like all these parts should be able to be printed on a 180 by 180 print bed, so like the A1 Mini or the Prusa Mini. So I hope that satisfies your sneak peek desires, Chris G. And then Draw says, I usually just use a blowtorch. It disintegrates any plastic. So Draw. So basically, I used to do the same thing. Like I would take like a torch and essentially just like get it so hot that like it was near glowing, and then I would just dunk it in water. And actually by dunking it in the water, it actually like causes like cavitation or whatever, and just again it would just blow off all the plastic. But then I learned that basically whenever I did that, I would like ruin the hardening process of the hot end, and so I'm trying to not do that again. But I may resort to it again if I keep getting these darn clogs. It's so annoying. What kind of printer do you have, Draw? Because I don't know. I keep wondering if I should just like buckle down and grab a Bamboo Labs, but it just sucks that they're so small. Like I wish Bamboo Labs came out with a 400, and I say this in every stream I have, but if you or if Bamboo Labs is here, or if you know anyone working at Bamboo Labs and they come out with a 400 by 400, I will review it for free. Oh, that would be so cool though. Like a large Bamboo Labs would be awesome. But again, I mean, I say that, but then again, just search on Google on people doing tutorials on how to like clear blockages, and a lot of them are for Bamboo Labs. So I think it's just like it's just gonna happen with any printer you have. Like there's just too many variables to like to account for. Like it's not just like how good the machine is; it's like the filament you're using. And even with this, like these are all the same brand filaments. So this is like I believe the brand is Arion, and it's like PETG carbon fiber. But I've noticed that like I can tell the difference between the batches, and I did dry them for like 4 hours plus. But I think it's just the nature of it. Like you can't really like fully control like the chemistry of some of these plastics, especially when you're adding like these fillers with carbon fiber and whatnot in there. There's just so many opportunities for things to go wrong. This thing is just not heating up well enough. I may resort to just taking a blowtorch to this, but I don't think I'll take a blowtorch to this guy though. I think I see brass and like stainless steel on here, so I won't do that. I think this is even copper too. So, but I think I definitely will take a blowtorch to this this hot ends. It should be able to take some beating to it. But this thing is just not getting hot enough. Man, my impatience is gonna get the best of me if I know it. Because actually what I could do is Cheaty Tech does give you 2 hot ends, and they don't just give you the hot end, they actually give you like the full heat break and even like the heat sink on there. The only thing they don't really add is the fan. So I could technically just like grab the the spare nozzle, like, so the spare heat break I have, and just put on this like hardened nozzle on there, because it looks like the nozzle should be clear, but I am able to push it now. So now I think I've got enough heat in here where I'm able to push the needle through. Now again, this is just a 0.4 millimeter needle, or it's designed for a 0.4 nozzle, and I think the heat break barrel, I think it's like, it can literally like fit like 2 millimeters in there. So being able to push through this needle is not really like showing that the clog is cleared. I think all it's showing is that I can get a thin needle through it. I think I might want to stop, because I'm seeing some like discoloration happening. Let me see if I can show it on camera. I have to zoom in with my face in here. Okay. Now you can't really see it, but I am seeing like slight discoloration on the bottom here. And maybe that's not the best thing. I'm probably going to ruin this by doing this. But yeah, the needle went through. Let me see if I can heat up this Allen key to go through. Because that would be like ideal, I think. If I can get that through, I think I'll be happy. But I might need to go through from the other side. I'm probably going to heat this up to the point where it's going to burn my hand though, but let's try not to do that. So Draw says, I didn't know about the throwing it in the water part. I should try that. Yeah, it's actually really cool, man. Like, it's one thing to have the hot end like get super hot to the point where it's glowing, but you can still see some of the plastic on there. But then the moment you dunk it in the water, it literally just like, it like blasts off. It's actually it's really cool to watch. I probably just did it mainly to watch than actually like fix. But yeah, if you ever get the chance, try it. But don't hold me responsible for breaking your stuff, though, because I think it does break the actual hot end if you do that too many times. Like I did that with a brass nozzle, and the nozzle actually deformed. It was actually pretty bad. I think it got so soft that like me holding it with the pliers ended up flattening the actual like the barrel of where the threads are, like right over here. And so do it on like a broken nozzle. Don't do it on one you actually intend on reusing. It's just fun to watch. And I think I just wasted my time here. I should. Okay, so basically I got the needle through each one. And maybe I just need to put it back in and tighten it all up and see if I can actually then like push through material. I even tried like using this like cleaning filament. I forgot what actual plastic it is, but it's supposed to like clear out material inside your hot end. But that barely worked as well. And I even tried doing like cold pulls and atomic pulls on that, and it still wasn't really working. I'm gonna try this needle again, but I should come from the top of it and not the bottom, because we do want to push crap out. No, it's cooled down too much again. See, I love 3D printing, but I also hate it at the same time, because like this is, not everyone has to go through this, but I think it happens often enough that like, yeah, if you just search on YouTube and just search hot end clog, there's like millions of videos of people dealing with this, and it's so frustrating. But at the same time too, again, it's just there's just so many points of failure. Like, if you've ever worked in an office environment and you look at a normal like inkjet printer, like those things go down all the time, even the laser ones. And so like, and those are pretty simple in comparison to 3D printing, in my opinion, because there's a lot more like mechanical things to happen in a 3D printer. But those things fail all the time too, and it's just frustrating that like our technology as human beings sucks. I'm kidding. It's all fun. I'm just really frustrated because I really want to show you at least the case like put together today, or at least the frame so that you can see like what components go in. But that just wasn't the case. And it also didn't help that I lost a few days being sick. But anyways, it's almost 1 o'clock. I think I've wasted my time and everyone else's time enough. Toma CNC, where is the case? So again, this is a sneak peek, Toma. You came in a little late, but basically, let me zoom out really quick. You know, let's just stop this. This is like fruitless. We're gonna let this guy turn off over here, and let me get this thing to track my face again. Okay, good. So Toma, new case is just a sneak preview today because I did have a hot end clog that stopped all progress, but essentially it is going to be micro ATX. I don't have a full-size micro ATX. This is like one of the smaller ones, so you can see that like in normal the large micro ATX, you'll see like 3 mounting holes near the bottom, and then you'll also see one more mounting hole to this side over here. So it gets bigger. So let me show you. So this is like the mounting pattern for a full-size micro ATX. And so you can see that this hole here matches up with this side here, and then obviously the other holes match up, but you can see there's one dangling over here. So like a full-size micro ATX will actually extend further out. And yeah, so this is one of the pieces, and they will attach to these 10 by 10 maker beams. Very similar to, if you've seen my other videos, obviously, like I made this one here for ITX. So this one had ITX, full-size GPU, but it only used an SFX power supply. But same concept. So essentially, like what you see here will now be this guy. It's like so much bigger. So, but the neat thing is, obviously, this guy could only use a small. What do you call it? This one can only use a small CPU cooler, and the hope for this particular new case is that it can accommodate for, let me see if I can come down here. It'll follow my face, hopefully. Wait, why aren't you following my face? Okay. Okay, so it should follow my, so sorry, it should fit basically a large format CPU cooler. And the plan is that you can basically use a lot of like common parts to make this next case work, because it'll also use a standard ATX power supply, but you are limited on the depth, but I think the majority of power supplies that are smaller are going to be 140 millimeters deep. And but it still opens up the possibility to like migrate a lot of people's systems, because it's micro ATX, air cooling, full-size ATX power supply, and a full-size GPU as well. So theoretically, this new case that I'm building should be able to fit a RTX 4090, the Founders Edition. I can't verify that because I don't have one, but if you know someone who can donate one, dead or alive, I could definitely use that and basically just verify all my claims. But for now, for sure, my RTX 3080 will fit in there. I also have this like super old retro gaming. This is a Radeon HD 6870. This was pretty cool back then, but now it's like the worst. That's not the worst. It'll still play some games, but obviously, excuse me, it won't hold a candle to the new video cards. All right. So Thomas says, is that the throat from a 3D printer? Yes, it is. So again, the stream today was basically to do a sneak peek of the case coming up, and then the rest of the time was supposed to be me trying to clear out a clog that I had, because I had a clogged hot end last night when I was doing some printing. This was actually the failure from that, and so yeah, this is like 90% done, and then the last 10% just kind of didn't happen because I had a clog. Like I walked by the printer and I heard like a funny noise. It was like a click, click, click. And normally when you hear that clicking, it means that the filament is just skipping on the extruder motor. And lo and behold, yes, it was a clogged hot end. And so I only needed like literally another 10% to finish this off, and I would have been able to show you all something like this for the new case, but stuff happens. And normally, you know, when I used to do more videos, I wouldn't show any of these failures. Like, that's why sometimes my project would take like a month apart, because not only because of the editing, but also like I would just run into these problems all the time. And I thought maybe it would be more interesting for people to find out what actually happens on the back end of all this stuff. And then Thomas says, I am staring at my Noctua NH D15. So I don't think the D15 will work for this. I know that I have a Peerless Assassin on the PC that's streaming this right now. So that's not, I'm not going to remove that. So that's why I'm using this like super old, this is a Scythe Ninja. And, but I hold on. But so basically Scythe Ninja. But the thing is with this one, I can't really show it right now, but the mounting allows me to move the fan up and down. And so let me see how far I can move it up. And I'll get some measurements off that to see if I can fit larger air coolers. But here's another thing though. So because of the free beam design, obviously these panels are like optional really, like they just kind of snap in. But it might be hard to see. Let me zoom in really quick. But even if you see here, you'll notice that the plane is flat on the outer surface, but on the inner surface, I actually did put like a slight bevel in there. Not a bevel, I guess. How would you say that? Basically, there's a surface change in here, and so what I'm trying to say is that if we really wanted to, we could just make the case thicker, and so that it could accommodate like wider things. And so hope is not all lost if the current design does not accommodate for a larger CPU cooler or a larger GPU. So no, that's not something to like get crazy over. Hold on, sorry, this camera's no longer tracking. Okay, there it goes. Okay, so yeah, so just because it might be like a few millimeters off, that few millimeters isn't like, it's not going to be the end of the world. Yeah. So what else we got here? We got, the case seems pretty cool. There are very few, if not none, micro ATX and full size ATX PCU 3D printed cases. Mostly are all for ITX builds. Yeah, so Drew, I totally agree. And if you look at my previous videos, if you haven't subscribed, I do have like I do have two case designs that utilize full ATX and full ATX power supplies, but each of those used a riser cable for the GPU. And one of the goals for this particular new case that I have is that I didn't want to use the riser cables because, again, I've had them fail on me, I've had them fail on friends, and obviously if you go online, a lot of them fail as well. So I think removing that one point of failure would be a really cool goal to have. And actually, before I forget, one of the things I wanted to ask you all was, so in this particular free beam design, I designed it so that on the outer surface, oops, you would not see any of the screws. And one of the things I'm battling with the current, the newer design is that I have come up with an idea to not have the screws visible, but it is causing a lot of, I guess, issues and complexity to the design. And so, again, so when you look at this thing, you don't see any of the screws, unless you look in the back, but nobody looks at the back. Well, some people look at the back, but anyways, you'll see screws here, but on the front, the top, and the sides, because it's all magnetic, you don't see any of the screws. However, I did want to ask, like, how would you all feel if, so the front of this won't have any screws. However, the side panels right now, I have designed an idea without using magnets. Unfortunately, though, it only worked for one side so far. I'm sure I could also just make it work for the other side as well. However, it just makes it super complex, and to be honest, I'm kind of over this case already. I want to move on. I want to move on to another case that's I think would be more fun. And so, what would be everyone's thoughts on having on screws exposed? And so, yeah, would love to hear your all thoughts on that, because it would definitely make designing it simpler. It would just mean that basically you would have to have more hardware for it. So if you look at this thing here, for every area that has a screw or a magnet, like, you would need Maker Beam hardware for it. I don't remember how much I used for this, but it was a fairly significant amount, and thankfully I had them. But I think as it is right now, for me to design the new case with screws, I would definitely have to dismantle this thing to recuperate some of the hardware. And I actually need to do an inventory check to see if I even have enough, even with this this case dismantled. So that is another factor as well if you're using this thing. So yeah, definitely things to consider when you do have screws, because the new design I was putting out didn't require any screws whatsoever. But it was all theoretical too. I don't even know if it's going to work in reality, because obviously I had the hot end clog, and so we don't know yet, but we'll find out soon enough, hopefully. But yeah, so would love to hear your thoughts on that. Let's see. Thomas asks material printer. So the material I'm using for this case, actually, it's the same thing for this case too. So I'm using PETG with carbon fiber. Now, PETG does have higher heat resistance than PLA, and the beauty of the carbon fiber PETG though is just there's no finishing on this. This is just how it came out from the printer, and in all honesty, it looks gorgeous. I mean, like, give me 1 second. Camera's trying to find me. Like, this thing was also printed out in the PETG with carbon fiber, and it just it's just a really nice filament. I think anything with like carbon fiber or glass fiber looks fantastic. It's too far, unless here, give me like 30 seconds. Count to 30. Probably more than 30, but like this thing here was printed out with ABS with glass fiber, and it also looks pretty sick. Like, so anything you print out with glass fiber or fiberglass just looks awesome, and it also has the added benefit. I think it prints out better than normal PETG. I really do believe that the fibers that are in there like kind of stabilize during the print, because I have noticed that like I actually have more trouble printing with normal PETG than I do with just carbon fiber PETG. So I love that stuff. Okay, so let's see, material. And then Thomas says, LOL, there goes my hopes. I think you were talking about the size of the heatsink, but I think we've kind of covered that. Yes, the recess. That's exactly what it was called, the surface change. And Thomas says big screws, industrial look. So you like that? I don't know. Okay. And then Thomas says, what about 20 by 20 framing? Is it too big? I do think it's too big, and frankly, I don't want to buy any more hardware than I have. I have like I actually have enough of these Maker Beam tubes. So right now I have 4 inside here, and then I have 4 more of these long guys. But I also have some 150 millimeter versions of them too. And if you follow my other socials on Reddit, I actually, like, maybe like 4 years ago, I did create a Maker Beam case that worked for ATX actually. I never really like released it. It was before I started making YouTube videos and sharing my designs. It was mainly just like an exploration on my end, but I may reintroduce that again. I think if you look at so I did that case like 4 years ago, but I think recently that other person, Jacob Designs, who charges for his designs, he put out like an ATX version, but it's very similar to what I put out like 4 years ago. Because I mean, there's really only so much you can do with these things, so that's why I think there's going to be a lot of like overlap in these designs. But yeah, so these 300 millimeter beams can allow for a full size ATX configuration. And in the one I made like years ago, it even had like crossfire on it, but the problem was you could only use SFX or SFXL on it, and so that's I don't have the L power supply anymore. I think I ended up returning it. It was like kind of crappy, but yeah, that's a lot of segueing. So let's see. Okay, so what about so you said like that clogs a lot. So again, so I think that the printer that I use is the Cheaty Tech X. Oh, it's not following me anymore again. Okay, so it's the Cheaty Tech X Max 3, and honestly, I've had it for what, maybe over 2 years now. I think I've had like 3 clogs on it, and I mean considering I've had tons of clogs with my Artillery X1, that thing clogged all the time. But that was more of like a heat issue. But I think I'm having just more clogs for this particular printer because, again, it is like a double-edged sword with these carbon fiber or glass fiber filaments, is that you are introducing more things inside the system to like clog. And so I think when I had reviewed this printer from Cheaty Tech, they also sent over some PET carbon fiber and ABS glass fiber, and I think they control the filaments they make, and so they didn't require a larger nozzle to have those printed with. I do remember there was a brand of carbon fiber filament that I did buy, and it said like, do not use it with 0.4 nozzles, and obviously I didn't follow that, and so that's why I'm not so mad that I'm getting these clogs, because I think it is also like partly on my end. And I think a year ago I did buy some 0.6 nozzles for this thing. I just haven't installed it. Like I have a lot of stuff around here that I bought, I just haven't opened or installed, and so that's just the nature of it, and it is kind of my fault, so I do apologize. All right. Thomas says those are very nice cases. Thank you. Yeah, they're really fun to make, and some of them I'm really happy with. I'll be very honest though. I say I'm over this case because I'm not a fan of joining stuff. Like if you watched my my Steam Machine replica, like I ended up just filling these in and painting it because I just couldn't stand how they look. But for this one, I'm not going to paint it. I'm just going to live with the fact that it's just like a joined piece, and it is just to accommodate and to satiate people with smaller printers. But in all honesty, I didn't print it in this orientation, but they were like, so this face, this face. So this thing can be printed on this printer in one go. I just didn't do it because I know I was trying to accommodate for smaller printers. But I know that I'd probably be more happier with this particular design if it was just designed around this printer instead of like a 180 by 180. All right, let's see. So Drew says, Drew or 4? I think it's draw. Okay. I don't mind screws. Maybe you could also make them flush or screw them a bit lower and then cover them with a plug or something for people who might not like them. That's true. And let's see if I have it here. I do have it here. So it's hard to see. I'm going to zoom in really quick. All right, so it is going to be hard to see, but this is part of the back panel, but no, it's difficult to see. Let me see if I can bring it closer maybe if I cover my face. But there is a, I guess a chamfer on these screws, the screw holes, and so it would allow it to sit flush, and if you did use like a black screw, it'll better hide it as well. So it is definitely another option for that. I don't know. So Thomas says, fully enclosed printer, leave door and top. Yeah, so that's definitely the case already, Thomas. So when I do print, this top cover comes off. Oops, let me zoom out really quick. Yeah, so the top cover comes off for this, and then I do leave this cracked open. But one thing though, like my garage is like, I'm in the garage right now, and it's freezing in here, so that's why I'm wearing a sweater. Let's see, it's currently like 63 degrees Fahrenheit in here, and for people not in the U.S., that's around like around like 16, 17 degrees Celsius, and so it's a cold garage, and so I've actually printed in here fully closed for PETG and even ABS. No, sorry, ABS does require, but PLA I mean. So PLA, PETG, I've done it closed because the ambient temperature is so low, it never caused any problems. But I really do believe my clogging is really just down to my nozzle size and the filament I'm using. So this thing does really well for heat management. Unlike my Artillery X1, that thing, oh man, that thing had like massive heat creep. Like if you want to talk about heat creep, that thing did it. Like, it was almost to the point where I was considering water cooling it, but luckily Tech sent me this printer to review, and it's now kind of like my go-to. I still use the Artillery X1 for really large spiral printing, because it does have a higher volume compared to this guy here. And then let's see, all my Voron 2.4 will clog if left closed with PETG. All have 0.6 and 0.8 and 1 millimeter nozzles. Wow. Yeah, so I think it could also just be that, Toma, your ambient temperatures are much higher than mine are, so you definitely need to open it up. And during the summer, though, yes, 100%. When in the summer, this place gets like, man, what is that? So let's see. I've seen it reach like, I have seen it reach like 100 degrees inside here, and so that's like close to 40 degrees Celsius. And yes, during that time, I definitely do I fully open it up. I even sometimes put a fan to it. And if you've ever watched any of my other videos, I did have an ATX case that I printed out using the honeycomb wall system. And because of the amount of retractions that were happening for that particular print, yeah, that thing was a clog fest. Like if you look at like some of my, I think I've showed it in a different stream. I won't do it right now, but I have like buckets full of like failed prints, which this is gonna now go into. But a lot of that was from that particular case because it did have so many like minute retractions, and I think that thing, it did cause some heat creep, and I think the heat sink just wasn't enough for it, especially because my ambient temperatures were just way too high. Let's see. Now Toma says it is now 5 degrees now in my shop. Actually, let's see. We're not. Yeah. So you're definitely a lot colder than I am. My God. Yeah. That is cold. I hope you have some gloves on. Yeah, I was just typing that about retractions. More retractions equals higher chance of clogs for sure. So one of the things I had to do for my Artillery X1 was literally just stop retractions altogether. It did cause a lot more stringing, but it just meant that my prints could actually finish. I don't remember which cases it was, but I think one of my popular cases, it's like the filament was like silver. It was ITX with a flex ATX power supply and a mini GPU. But that thing, man, I luckily for that one in particular, I had a clog so bad that like no, sorry, not only was I having some clogs, but I also had a power failure on that one, but I was able to like fix it. So, but yes, retractions definitely do add to the chances of clogging because of just the heat creep. But yeah, so again, luckily I was able to be successful in showing you the sneak peek for the next case. Wasn't too successful for the hot end issue, but we'll see. I'm gonna put it back in later on and try some prints out, and hopefully I've done enough agitation within the heat break and the hot end so that the clog, whatever it was, can be pushed through when I push through filament again. And if not, I will probably just resort to either using my spare heat break and then using the hot end that I have now, or literally just buying a new hot end and heat break. No, I won't buy a new heat break. I'll probably just buy a new hot end if this one doesn't work out. But um, yeah, so that was that. And if you have no other questions, I think we can stop the print now. I mean, sorry, we can stop the stream here now because there's really not much more to go over because you can only go so far with the sneak peeks, and obviously I was kind of a failure on the repair of the hot end. And then let's see. By the way, I'm also Toma.3D and Toma.PC here on YouTube. Cool, yeah, I'll definitely check out your channel, Toma. And thank you so much for stopping by and chatting and asking questions and just watching. So yeah, so if there's no other questions, I'll wait like a few moments. I know there's a slight lag to whenever I'm asking a question and then an actual thing pops up. So, but if there are no other questions or comments, I'll probably just stop the stream then because I do want to put this thing back together, and there's no point in showing you that because it'll be just too far for the camera to see anyways. And maybe I'll take some NyQuil and go back to bed. All right, you're welcome, and thank you for the great case. So Thomas says you are welcomed, and thank you for the great cases, and he might just print one out. Yeah, cool. Yeah, so let me know which one you do print out. There's definitely a few options. Some of them are definitely more limited. So one of the goals for this next case was that it should be more generally accepted or utilized by many because, like for instance, this one required a very specific riser cable. A lot of them actually require some riser cables and hardware. Like for instance, this one here it not only required a specific riser cable, but it also required you to dangerously modify and utilize a power supply that could potentially kill you or burn down your house. So hopefully this next case I'm designing, sorry about that, the next case I'm designing won't have those limitations. So with that, thank you so much for joining, and if you're watching this after the live stream, thanks for watching. If you haven't subscribed, subscribe. If you like this kind of stuff, let me know. And if you also want to support the channel, I do have a Patreon. So on the Patreon, I actually showcase some of my work before anyone else sees it. And so people on the Patreon have already had like better, clear sneak peeks of this. And they have also voted for this particular case. And so I do have a voting system there so that my members can actually vote on which case can be made next. And depending on the level that you do donate at, you could also even suggest cases. And so if you're interested in that, the link to my Patreon will be in the description, and you can also just find it on my socials as well. Cool. Sorry, someone just printed something. So Thomas says, I have a Voron 2.4 that can do 4060 by 4060 by 1200. Oh my goodness. That's crazy, Toma. No, so where I'm subcontracting right now, they do have a 3D printer that's like longer than my arm span. But 460, that's... All right, Tom, I'm gonna check out your channel. That sounds pretty interesting. I hope that you have some footage of that thing in action, because that is crazy. 460 by 460 by 1200. Yeah, you could print anything. You could do like EATX with like a full size power supply. Oh my gosh, you could do anything. That's amazing. Toma, have you ever printed out with these PETG with the carbon fiber in it, or even like I know they came out. They have some for like PA as well too, or yeah, I would love to know. There are some bad videos there. Don't call them bad. I'm sure someone's gonna learn from them. I mean, just like the stream too. I'm sure like the quality of the stream is just like not the best, but whatever. Let's see. No, just normal PETG. So if you ever get the chance, Toma, like, despite all the downfalls I've had printing with this stuff, again, it is amazing stuff. Like, it's too far and it's too hard to get, but like, I did print out an ATX version of one of my 3D prints, and one of the side panels fully utilized the 320 by 320 bed on this thing, and it obviously took a long time to print, but the end result was fantastic. And so Yeah, when you get the chance to try out the carbon fiber stuff. And honestly, I know that normal PETGs are in the US. It's around like the ones I buy are around like $20. Uh, but oftentimes I'll see these guys go on sale for like 21 or whatever, or like. But generally they're below $30 for like the run of the mill ones. But I think it's worth it. That the extra whatever percent is like, in my opinion, totally worth it. Because again, I actually have a way easier time printing out with carbon fiber than I do with normal PETG. And that same goes for like, again, this is ABS with carbon fiber in it, and this isn't the best showcase, but like it prints out really clean, and it is technically more brittle than PETG, but it is definitely stiffer. Like I normally I was printing out with like 7 millimeter walls, but because the carbon fiber does provide a lot more rigidity to the filament. Like for now, this is a 5 millimeter. I probably should go wider, but I think it'll be fine. And then let's see. PET. So Thomas says PETG transparent or translucent also looks nice. So I've never actually like done too much on that. So I've done like small pieces of transparent filament. If you look at like my steam machine replica, I did print out like a little light ring that used transparent filament. And it's funny, for that particular build, I was trying to make it so that it was like super translucent, but I just failed at it. It could have been my printer, I don't know, but it definitely is user error more than likely. And then so Draw asks, okay, so this is a funny question. So how many 3.5 hard drives this new case will hold? And the answer is a whopping 0. So I mean, so right now, so like let me show you really quick. So because I'm using old part. I don't have. Sorry about that. I don't have a spare system I can build for this new case. So I am utilizing that super old motherboard. Where did I put that thing? Oh, it's right in front of me. So yeah, this is like super old. Obviously, this is from 2008 or whatever, or maybe earlier, later maybe. But anyways, it's old, and so I don't really. So normally I design for NVMe. I just love NVMe, but for this particular one, I did have to use a 2.5. So there's even a bracket for it. Like this was like last minute choice because I was like, oh shoot, I need to make a bracket for this thing. But as of right now, they're really, there is space for 2. So I'll just spoil it. So basically, in this particular design, it is designed for air cooling. However, I have some mocked up things for some of my radiators. For instance, I have like radiators that are normal size. I have some pretty thin radiators, and I noticed that I could technically put in a thin radiator in there if you don't utilize the top or the bottom slots of your micro ATX, which I think most people don't. So you could technically fit in like 2.5 hard drives if I put in an adapter. I mean, I'll make an adapter and throw it in the files. I'm not gonna test it. I think I have like one hard drive, and one of the hard drives actually I dropped like yesterday directly on cement, so it's probably dead. And so the answer is a maybe. Like I will add in the files to accommodate for 3.5, but I'm not gonna test it. But I'll just put it in there. So that's my answer to that. The official answer is 0, but the big maybe is that you could technically put 2.5s. Actually, if you use the case with an ITX, then you could probably put in like 6, maybe. But they won't be hot swappable. All right, and so I'll leave it at that. So then Toma asks, PETG at 265. Yeah, it's pretty hot. So if I ever printed that hot especially with my Artillery X1, I am 100% getting heat creep in a clog. So funny enough, the PETG with carbon fiber that I print at, I use the stock profile for PETG. Now, normally they do recommend that if you're using filaments with, um, you know, you use filaments with the glass fibers or carbon fiber, you should up it. But I actually just leave it at 250, and I mean, besides obviously the clogging of the material, maybe, like I've had no issues, and honestly, it prints so well. Again, I don't know if you came here earlier, but the interface fits, the interface fits I'm putting for this. I did a bunch of these tests. Like these are some of the tests, and some of them don't even work, like because they were just the tolerance is too high. But for my particular printer, I don't know if it's gonna work for everyone, but uh, this is going to be using a zero tolerance interface fit, and I was really surprised that it even worked. So I had to use a hammer, like the back end of a hammer, to make this fit. But like for these test pieces, I was able to just kind of just push this with my own like palm, but it's pretty stiff. So like these are different tolerances, but what I landed on was the zero tolerance, and so amazingly enough, like it still fit, and obviously it fits really well. I think for added security, I might put like dabs of super glue in here, or even just melt it with my soldering iron. I don't know, but like yeah. So you mentioned your PETG printing at 265. I only print at 250, and so far it's been working really well, and the accuracy has been fantastic for me. And let's see. So FWA says high carbon fiber or high glass fiber for ABS is good for sort of high temperature applications. In general, carbon fiber and glass fiber makes weak the layered head. Yeah, for sure. I think I forgot which YouTube channel there. I think maybe it was CNC Kitchen, but they did like a test on uh, carbon fiber and glass fiber filaments, and they did find that basically you do create a more brittle uh, filament by doing that. And in actuality, like if I go to the Cheaty Tech website, they even say that if you are printing out these materials, you're supposed to anneal them. I have no way to anneal these. I don't have like a. I do have like a spare oven that I have, but it's like it's too small to utilize any annealing for that. So, I think I think if you do anneal it, I think it does bring back some of the properties that PETG will have. In my opinion, I bet you any money that a properly annealed uh, carbon fiber glass fiber print should match or even outperform a normal filament, but it needs annealing because you do need to like restructure the whatever the structures within the filament to make that happen, and it just won't happen when you're like laying down layers. And so yeah, that's definitely the truth for that. Let's see. Uh, so Jaw says, no, it would have been very good for NAS. You know, people keep talking about NAS, and I think Maker Unit makes a pretty good one. I know you have to pay for it, but I think it's not that much. I think it's like $5 or something. So, and I did say in his video, like, if anybody else asks me to make NAS, I'm just gonna point him to that video. So if you go to Maker Unit's website or his YouTube channel or even his printable site, he does have an NAS system there that is hot swappable. And the stuff he makes is fantastic stuff. Like unlike me, I think he actually does take more care to the design because like he's charging for them. I'm not, so you're basically getting like sketches. Um, but for NAS, yeah, go for something else because what you would call it I have like again I think I had two 3.5 hard drives, and yesterday I dropped one on the cement, so I probably only have like one, and right now I haven't really needed it, but I'm probably gonna regret saying that with more videos that I make. Um, but yeah, so again, a lot of the stuff I make is for stuff that I want to do and that I need or that I'm interested in. And so far, right now, the NAS has not popped up. But again, if you are a member of my Patreon, depending on the tier that you use, like the highest one, basically you get to like kind of decide on what's up next. And so that is an option for you if that's something that you're really interested in. Let's see. Let's see. Thomas CNC says anything that can fit a 420 milliliter Arctic water cooler. Theoretically, I probably could expand the honeycomb wall system PC that I made, because that particular case does use a 360 millimeter radiator. But the nature of that particular case, it does open it up for expandability, both like height, width, depth, because it does just use the honeycomb wall system. It won't be like a complete like easy modification, because some of the mounting holes are particular to each panel, so it's not just like you can just print out a honeycomb wall system and expand it. No, I take that back. Technically you could, because the outside of the case is honeycomb wall system. You could adapt like another container to it. So the answer is like a very high maybe yes. But in the future though, if I ever have my hands on a 420, maybe. But right now I don't have one. The largest radiator I have that's for PCs is 360 millimeter. I do have another radiator that's been in my backlog for like over, I want to say like 6 years now. If you go on my Reddit, I posted like this this Craigslist find. I found this copper radiator for a car. It's like yay big, and I just haven't gone around to actually attacking it. Like I even bought like these two large like 20 centimeter fans for it. And it's not my first foray into modifying like an automobile radiator for water cooling. If you looked at my other like Reddit posts, like I like back in like 2000 and maybe 3 or 2005, like I think back then like I had to use a heater core to do water cooling, so like it's not like completely alien to me, but I just don't have the time right now. But it definitely will end up. Actually, my goal for 2025 is to finish that project. So by 2025, you will see a project where I utilize that huge like car radiator for PC. Like you heard it today. All right, so let's see. Toma says he's getting coffee. Right on. Toma, where are you actually? It's already like 1:30. Why are you getting coffee? You must be from like somewhere else. So FWA says, I have a Voron extruder printed out of ASA glass fiber and it works great, but something like motor mounts didn't work as expected. Did the motor just overheat and that's why it like did it deform? Is that what happened? Because I know that like you can like these things can take, they have a glass transition that's pretty low actually. I think it's like 90 degrees or even like 70. And then when you hear that, it's like, oh wow, they have a glass transition, meaning that they'll become like super flexible and like almost rubbery by that temperature. But the chances of you actually hitting that temperature is quite low, because unless you have this directly on like a CPU or a GPU, it's never really gonna hit that, because for you to hit 70 degrees Celsius on the plastic, it would mean that the air itself would have to be that hot, and unless you have the part directly like right beside it, it's not going to be the case, because if your air is like 70 degrees, like you are in more trouble. The glass transition of your filament is probably the least of your worries. If the air itself is like 70 degrees, that's like you're like in a boiling room. So I love hearing people talk about that. But again, if it is really close vicinity and it is actually touching, then that definitely is an issue. But if it's just like around it, like that's not really a big issue. Yeah, so I'm just waiting on the answer, if he does answer about the motor mounts, because I'm assuming because they were directly mounted, it probably did deform. And you mentioned that your extruder printed out ASA glass fiber, and that I'm assuming that's just for the case. Okay, so the layer adhesion doesn't survive all the forces of Voron, so that's why ABS Plus is my go-to for big parts and computer cases. I guess your experience may differ with... Okay, so you're actually like you had mechanical issues. Wow, that's yeah. So I mean, yeah, to your point, I think because my PC cases are all I mean it's static load, right? Like once you set it, like obviously if I had this filled with a PC, maybe not this one because it has a metal beam in there, but like for instance this thing here, if I had this in my backpack or if I just running around with it, obviously I think I would definitely probably experience what you're experiencing in that like you know you basically are starting to break the plastic itself, but because in my opinion, for PC cases, you should never be subjecting them to dynamic loads. It should always be static loads, and so never an issue on my part. But again, like I don't ever say like, oh, you should go on an airplane with this thing because like that's a different story, right? So I think to your point, yeah, I think that's like it's fascinating, but it's also not surprising that like because of the static loads on that particular part, yeah, I think that you probably would definitely notice more like the weakness of glass fiber. So makes total sense. But actually, I mean, if it's a small motor mount, so I have like a spare oven that I got for free off of like Craigslist or something. I had other plans for it, but I'm curious to see. I mean, I'm not gonna ask you. I guess I am kind of asking or maybe suggesting that if you could try like annealing your parts that are done with glass or carbon fiber to see if it'll make a difference. Because my theory is that it would. I think the annealing should help it. But again, that's just all in my head right now. And let's see. And I was wondering if there aren't any vibrations caused by. There definitely will be. I think, but I don't think they're going to be enough for the case to like degrade that much. Because that would mean that you would have fans that just suck. Like if your case is vibrating so much that like you become concerned about the integrity of the actual material, you need different fans because that's like if you can, yeah, that's a lot of vibration. I think that like you should just get higher quality fans. Like I mean, so for instance, this is the Arctic like what is it the P12, and these are fairly cheap. I think they're like they sometimes go on sale. I think when I bought these were like $3 each. I bought like a 6 pack for like whatever dollars, and they are fantastic. They barely make noise. The vibrations are very low. Now I also have fans in like my spare box that are like you can use them as like a vibrator for a girl if you wanted to. So I get that point, and I think like if you had a case with just those types of fans, that would probably be an issue. But I would advise to not have fans like that because you can get really nice PC case fans that are quiet, they don't vibrate. I think back then, like I remember way back when, like the fans we had available were all like server grade. Like, I remember like you'd have like Delta fans that could like lop off fingers and stuff. But we don't live in that state anymore. Like where we have like really nice fans now that are pretty cheap. So I don't think that's gonna be so much of an issue. But again, to that point, if you are 3D printing your PC case, definitely don't move them around like constantly. Like I think for me, like when I make my videos, I probably move them around way too much, and I haven't had any issues, but I can imagine if someone's not careful enough, like yeah, you could definitely break your PC case because it's essentially plastic. So that I totally agree with you on that end. Okay, so I said it ended at 1 p.m. It's way past 1 p.m., but I really do appreciate again the questions and comments you all have. Again, if you haven't subscribe. I'll try to have more of these streams up more frequently. And again, if you're interested in suggesting cases or voting for new cases, the Patreon does allow you for that. And by joining the Patreon, you do get like a sneak peek of what's happening with better detail, obviously. And you also just basically help this channel because like all this filament gone, and so that's going to be and I'm thankful for the Patreon members I do have because they allow for these silly mistakes to happen. because the money they put in basically just goes to buying 3D printing filament, or I guess in this case maybe a new hot end. So let's see. FBWA. Let's create one for under the table case. So were you in the previous stream for this thing here? Do you remember this thing? So this was bought during Black Friday. It was like I think $20. And one of the suggestions for this was to actually create an under the table case. And so, I mean, I'll spoil it. This is it's not going to be the next case after the Micro ATX, but it'll be soon after because it is definitely low hanging fruit. Like I don't intend on fiddling with the finishing too much on this, and so this will be. Let's create. Okay, so FBWA. Sorry, I'm like burping. I got this case during Black Friday. Super cheap, $20. It had like a way larger shell with like plastic cladding all over the place, but one of the suggestions from one of the viewers was to create an under the table desk. Give me 1 second here while I'm gonna take off a part here really quick. And basically, within the case, there was actually a pretty cool little chassis, as you see here. So it's a cool little chassis. It's ITX, full-size GPU, ITX, and it had a space for a SFX power supply. And essentially, like, there's really, I mean, technically, like, I wouldn't even need to 3D print anything for this. I could literally just use these existing holes and just, like, literally drill it. Maybe I should just do that. Maybe that's, like, just one little, like, YouTube short where I'm like, this is how I turned a $20 case into a desk case or whatever. Yeah, so I mean, this would be like super low hanging fruit for that. One thing we could also even do is just hang it this way so that we could put in like a huge cooler without needing like the case. I guess that could also work this way too, but yeah, this definitely is like an option for that. And if you subscribe to my channel, there is also the Steam Machine replica was originally going to be an under desk case because I was having so many problems designing that case, but I just wanted to put something out, and I was like talking to my buddy, and I'm like, he's like, you should just make it into an under desk case. I'm like, oh my god, I'm so tempted to because I'm so over this case right now, but I ended up just pulling through and finishing the case. But under desk has definitely been on the backlog for a while, so maybe it'll be put on the list for my Patreon members to vote, and they'll see what they say about it. And let's see. So FBWA says, yo, you live in Helsinki. That's Europe, right? I think. Let's see. I printed out sort of a base for my ATX and just screwed it to my table. It doesn't look nice, but it does the job. Kind of sliding option sounds sexy. Oh yeah. And to your point, yes. I mean, the beauty about an under the desk case would be that it would generally be out of sight, right? So I think that's why I was mentioning that if I ever do try to pursue using that chassis for under the desk, like I'm not even gonna fiddle with the finishing, because like who's gonna see it but you when you're working on it, right? I think that's the whole point. But having a slide out option would be really sick, because then if you are doing maintenance, like for me, like I don't have filters on my cases, but I do use an air blower to clean them out every once in a while, and so that's definitely a good point. Because my desk moves up and down, so your idea sounds cool. Yeah, for sure. So that's cool. Yeah, so I mean, I don't know if you know, but like my handle is stand up gamer, because I actually do play games standing up. I don't like sitting anymore. And so to your point, yeah, that definitely would be awesome to have a sliding desk, or sorry, sliding rail for the desk. Okay, yeah, so Finland. Wow, so yeah, thank you for staying up to watch the stream, FBWA. I really appreciate that. And would love to one day visit Finland. I've done like a little bit of Europe, but not so much. I'm saving it from much older, but I do remember like I had plans to go to was it Greenland, but then COVID hit and it just kind of ruined everything. But I definitely will make a little trek through Europe eventually one of these days. I've only been to a few countries there. But okay, I'm definitely way over than the 1 p.m. that I said. Again, thank you so much for joining the stream. Thanks for all the questions and comments and chatting with me and providing like a lot of the information you guys have. And so, yeah, we'll call it good there. And again, thank you so much. And we'll definitely see you all very soon because I do intend to have these streams more frequent. And essentially what it means that you're just going to see more of the behind the scenes, just like this, like all the failures and all the struggles I have in creating these cases that I share for free for all of you all. Let's see. So FBWA says 1 day is enough in Finland. And they say that they're playing PUBG standing up as well. Yeah, I get massive back pain if I play games for too long sitting down, and I find that it's kind of dangerous, I guess. It's also, they did studies and they say that it's actually not healthier standing than it is sitting. You just use more calories standing up, but you're still putting like a lot more strain on your body by like standing up. But I don't know. I'm like, my back feels way better standing up gaming. So anyways, yeah, thank you so much for joining. I know this always takes me a while to actually stop the stream, but what I'll do is I'll press stop and then say goodbye. So pressing stop now. And goodbye. Oh no, I screwed up again. There's like these little prompts that come up before I stop the stream entirely. So, okay. Goodbye, and thanks for joining, and see you soon.